Alright, here we go. We're going to try a little something new today, guys, so just bear with me. If you hear a little background noise, that's my class out there being little crazy peeps. Got to give the Elmo a second to warm up. And we're going to go ahead and do these review videos, but there we go. Alright, number one. So if you look at number one says we have sine of x plus the cosine of x, quantity squared minus 1, and we're just simplifying. So please again write this out. Sine of x plus cosine of x times sine of x plus cosine of x minus 1, distributing the sine x. That's going to give us sine squared x plus sine x cosine x plus cosine x sine x plus cosine squared x, and then we have the minus 1. So sine squared plus cosine squared, that's 1, and a minus 1 are going to cancel. And then we have sine x cosine x and a cosine x sine x, which really just makes 2 sine x cosine x, which that really is the same thing as sine 2x. And there you are done. Alright, number 2. Number 2 says we have 1 minus tangent squared x over 1 plus tangent squared x. There's actually a couple ways to look at this problem. Personally, I like to look at 1 plus tangent squared x and think of secant squared x. We have 1 minus tangent is sine squared over cosine squared. Therefore, now we want to get a common denominator here. So that's going to lead us to cosine squared x over cosine squared x minus sine squared x over cosine squared x all over 1 over cosine squared x. Combining the tops, I get cosine squared x minus sine squared x all over cosine squared x. I don't like to divide by a fraction, so I multiply by its reciprocal, which is going to be cosine squared x over 1. Cosine squareds will simplify, leaving us with just cosine squared x minus sine squared x, and that is cosine of 2x. And we are done. Number 3. So number 3 says we have 2 tangent x of 1 minus sine squared x. Okay, well 1 minus sine squared x, that's the same thing as cosine squared x. Tangent is sine x over cosine x. One of these will simplify one of those, leaving us with 2 sine x cosine x, and we've seen that before, which is just sine of 2x. Again, done. I realized I didn't scoot up my paper on number 2, so I don't know if you guys saw that, sorry. Number 4, we have sine to the 4th theta minus cosine to the 4th theta all over sine squared theta minus cosine squared theta. Well, if that's the case, I would tell you to look at the difference of squares. So on the top, hippo butt, sine to the 4th is what? Times what? Sine squared times sine squared. Cosine to the 4th is going to be cosine squared. Cosine squared. One's a positive, one's a negative. All over sine squared theta minus cosine squared theta. These two will simplify because they're exactly the same. Sine squared plus cosine squared is 1, and you're done. Number 5. So number 5 says we have the sine of x plus pi minus the sine of x all over the cosine of x. So who's choosing? Sinbad is choosing. So that gives us the sine of x cosine of pi plus, I said pi and I wrote x. Give yourself a full class to get sine of pi cosine of x minus the sine of x all over cosine x. Well, cosine of pi is a -1. Sine of pi is 0, so that's going to cancel. That's going to lead us to a negative sine x minus sine x over cosine x, which really leads us to negative 2 sine x over cosine x. Now, if you can't see it, you could write it as negative 2 over 1 times sine x over cosine x, which that then leads us to negative 2 tangent of x. And we're done. All right. Number 6. Number 6 says we have the cosine of x minus 3 pi over 2. Cos z is choosing, so the cosine of x, cosine 3 pi over 2, they're opposites. Sine of x, sine of 3 pi over 2. So remember, 3 pi over 2 is right here. Cosine of that is 0, so that's going to cancel. Sine of that's negative 1, so this is leading us to a negative sine x. Done. Number 7. So number 7 says convert negative 3 pi over 6 from polar to rectangular. That means we're going to be given an r and a theta. We got to get to x and a y. So I'm not sure if you remember the equations, but on your homework, it does say that on your notes, x equals r times cosine theta, and y equals r times sine theta. So if we look at that, x is going to equal negative 3 times the cosine of pi over 6. Y is going to equal negative 3 times the sine of pi over 6. Unit circle, pi over 6. Cosine is the x value, so is this x value the long x value, short, or middle? It's the long. So this got to be square root of 3 over 2 times negative 3. The y value is the short y value, so negative 3 times 1/2. So my point is negative 3 times square root of 3 all over 2, and negative 3 over 2. Done. Number 8. So number 8 says negative 3 negative pi over 2. So therefore, again, we have an r and a theta, and we want to get to an x and a y. So x equals r times the cosine of theta, y equals r times the sine of theta. So therefore, x equals negative 3 times the cosine of negative pi over 2. Y is going to equal negative 3 times the sine of negative pi over 2. So unit circle, negative pi over 2 just means we come this way to here. So the x value is 0, the y value is negative 1, so this can be 0. So that means this is going to be 0. This is negative 1. Negative 1 times negative 3 is 3. And there's your point, 0, 3. Now if you think about that, look back up here at this polar point, negative 3, negative pi over 2. So I came this way at pi over 2, and then instead of coming out to the third ring like I should have, right? Instead of coming out to the third ring here like I should have, the negative radius shot me in the opposite direction, which tells me I need to go up 1, 2, 3, so it's right there, which really is exactly that same point as 0, 3. And we're done. All right, let's take a look at number 9. Number 9 says negative 3, negative 3. Now we have a rectangular point trying to go to polar, which means we have an x and a y. We're going to try to go to an r and a theta. So if you don't remember this equation, you can always draw the graph, plot the point. Remember, this distance right here is r. You can make a right triangle. That's terrible. Sorry about that. This should have come down. This should have been right here. So this is 3 and 3. So Pythagorean's theorem would say that I have 3 squared plus 3 squared equals r squared, so I need to take the square root. So 9 plus 9 is 18. Square root of 18 equals r, which 18 is 9 times 2, so the square root of 9 is 3, square root of 2, and that equals r. Okay, we'll find theta here. So now to find theta, it says usually the theta is equal to the inverse tangent of the x value, or the y value, negative 3 over the x value, negative 3, which really means the inverse tangent of 1. Well, there's only one place the tangent is 1, and that's in my 45-degree angle, because that's where it's square root of 2 over 2 and square root of 2 over 2. But notice this point up here is in the third quadrant, so that means it's got to be 225 degrees. So there it is, 3 square roots of 2, 225 degrees. Alright, let's do number 10, and I think I'll probably end this video and start a new one here in just a minute. Negative 2 square roots of 3, again going from an x and a y, trying to get to an r and a theta. Yep, have a great day, folks. Simply schedule. So here we go. We're going to say that if we take negative 2 squared plus negative 2 square roots of 3 squared, and the square root, that will equal r. So this is 4 plus 4 times 3, so 12 plus 4 is 16. Square root of 16 is 4. That's equal to r. So I know my r is 4. Now I need to find theta. So theta is equal to the inverse tangent of y over the x, which is really then the inverse tangent of the square root of 3. This then has got to be one of my either pi over 6 or pi over 3. So remember, I'm going to take the y value over the x value, which in this case is going to be 1/2 times 2 over the square root of 3, which is 1 over the square root of 3. So it's not my pi over 6, it's got to be this one up here, pi over 3, or 60 degrees. And if you look at that, you get square root of 3 over 2 divided by 1/2, which is times by 2 over 1, which really then is just square root of 3, which is what you wanted. So it's 60 degrees, but they want it in degrees, so there it is, 60 degrees. Make sure you're in that quadrant. So let's look at that point. That point is negative 2 square roots of 3. So, oh, it's in the third quadrant as well. So it's the 60, one that matches the 60, but in the third quadrant. That's going to be 240 degrees. So there it is. And you're done. Okay, I'm going to stop this recording. We'll see how it turned out. I know it was pretty loud right there, and I apologize. So sorry about that. Holy cow, man. You guys knew I was recording, so it's like, let's get as loud as we can. I know. I was like, I was just teasing about you wanted to be on the video.
Oh, can I ask you a question?
Yes. No, I stopped.
So that
Rocky!
you were helping me out with what day it was